Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also, click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 38, which is based on the fluid conditioner. Air is used in pneumatic system must be clean and dry without any contamination like traces of oil, water vapor, dirt, dust, etc. Presence of these leads to wear and frequent trouble and breakdown of the system. Atmospheric air contains smoke, dust, moisture which are harmful to the mechanical components of pneumatic system and needs to be treated before it is stored in the receiver or used. Removal of harmful elements from compressed air is called preparation of compressed air. Now, compressed air is prepared or treated in three stages, which you can see in the block diagram over there. First one is called as filtering before the air enters the compressor. Second one, cooling and drying after it has been compressed. Finally, the local treatment is removing dirt and moisture and mixing with a small quantity of oil. Now let us understand how does it work in stage 1. The air before entering the compressor is to be free from dust particles and for this filter is used. If not filtered, the contamination may damage the internal parts of the compressor. Stage 2, due to compression of the air gets heated up, this need to be cooled and dried to remove moisture content with the help of a dryer. Cooling and drying treatments are also referred as primary treatment. After primary treatment, the cooled and dry air is delivered to the receiver. Stage 3. The pressure air from the receiver before being used into the actuator is again filtered and dried using filter and dryer. Depending on the use, air is mixed with a small amount of good lubricating oil to assist in lubrication. The third stage is also called as secondary treatment. Then coming to the next concept of the fluid conditioners, they are called as filters. The primary function of a filter is to arrest dirt and smoke particles entering the compressor, pneumatic elements and actuators to prevent damage to them. These filters may be a dry filters or wet filters based on the applications. The figure shows the same. In case of wet filter, the air is bubbled through either water or oil and then passed through fine mesh of filters. The purpose of this is that the dust and the dirt particles get attached to the liquid droplet during bubbling and consequently removed by the wire brush. Then coming to a dryers, which is called as a chemical dryer. During compression, humidity and dew point of air increases. To bring the level of humidity and dew point to a reasonable level, the excess moisture is to be removed. In bulk air system, the air is passed through a simple cooler which aids in condensing the moisture and drained off. The figure shows the typical water trap separator with its graphical symbol. Air enters the inlet of the unit, undergoes a sudden reversible in its direction of flow and swirls with the help of a deflector cone. Both actions of reversal of direction and swirling causes heavier particles to flung out of the separator wall and get collected at the bottom of the unit. Dew point is further lowered with a refrigerator dryer which chills the air above 0 degrees centigrade, condensing almost all the moisture in the air. Refrigerator drying reduces dew point sufficiently low, which may not be desired in most processors when absolute dry air is required. Chemical dryers is employed, which you can see in this figure right now, shows the principle of chemical drying. In this case, moist air is passed through chemical agent called desiccant. The chemical agent absorbs moisture and slowly forms a liquid which collects the bottom of the unit. The chemical material needs to be prepared at a regular interval to maintain its efficiency. Chemical dryers are referred as desiccant dryers or absorption dryers. Coming to the lubrication parts, which is called as air lubrication, to reduce friction between moving parts in pneumatic system, the compressed air is mixed with a controlled amount of oil before being used. As discussed, the presence of oil in air is a contamination for process controlled pneumatics, which requires clean and dry air. Oil addition is generally carried out during the secondary treatment of air, as it is difficult to store the oil mist laden air in the required state in the air receiver. The figure shows the typical air lubricator, and the function of this is similar to the carburetor in an automobile. As a series as a series of air enters at the inlet, its velocity increases and pressure reduces due to Venturi effect. This pressure difference at the inlet and after Venturi effect cause the oil to rise in the riser tube. This oil comes out at the inlet point of air in the form of fine spray and mixes with the air. A needle valve adjusts the pressure difference across the oil jet and hence controls the oil flow rate. The air oil mixture, because of high velocity of air, swirls. It leaves the central tube, resulting in excess large particles of oil thrown out of airstream and falling back to the oil bath. Coming to the next concept, that is called as air pressure regulator. The compressor's control system maintains a system air pressure within a given range whenever there is a drop in the pressure in the receiver within the range. The compressor may start automatically, and similarly, when the pressure in the receiver reaches the maximum value of its range, the compressor may stop automatically. This is generally accomplished with the help of a pressure switch. A relief valve is provided as a standby to protect the compressor in case of pressure switch fails. The viscosity of air is very low, and hence the flow velocities in pneumatic systems can be high, which can lead to significant flow dependent pressure drops between air receiver and the load. This necessitates the local pressure control. The essentiality of three methods of a local pressure controls, which you can see in the present figure, which is shown in the slide. In all the three methods, the pressure regulator is applied. Let us discuss the method one by one. Method 1. In this method, the pressure regulator simply restricts the airflow to the load. This type of regulator has two ports and requires some minimum flow to operate. If used with a dead end load which draws no air, the pressure rises to the main manifold pressure. Such regulators in which the air must pass through the load are called non-relieving regulators. Coming to method 2, in second method, the regulator vents air to the atmosphere without passing through the load. This type of regulator has three ports, one for supply, one for receiver, and the other for vent, and are called relieving regulators. Coming to the third method, in third method, Load is quite large and flow requirements are beyond the capacity of ordinary inline regulator. Here, pressure control loop comprises of pressure transducer, electronic controller, and a separate vent valve. This method can also be used if pressure regulating valve cannot be maintained locally at the point where the pressure has to be controlled. Then coming to the FRL unit. With the advantage of manufacturing and machining technology, the independent devices for controlling the compressed air, that is filtering, regulating and lubricating, is combined into one unit which is known as FRL unit. FRL unit is so designed that it serves the functions of a filter, regulator and a lubricator as a compact device. The sintered filter with a water separator removes the dirt, pipe scale, rust and condensate from the compressed air. The regulator is a diaphragm operated relieving type of regulator. The regulator keeps the working pressure of air fairly constant irrespective of pressure fluctuation. The lubricator is a mist type. The required lubrication is set by adjusting screw feet done. The amount of oil atomized is proportional to the airflow. FRL units are connected upstream of the pneumatic system, which saves the space and improves the efficiency of the system, and the respective figure shows the line diagram of the FRL unit which you can observe. Then coming to the difference between pneumatic and hydraulic systems, we are going to discuss each and everything one by one. In pneumatic system, uses air as the working medium, whereas in hydraulic system, oil is going to used as a working medium. It is an open system, it is a closed system. Every time fresh air is drawn and the same oil is used again and again. Cannot provide high volume pressurized air on demand, can provide high volume of pressure oil on demand. Suitable for low pressure application, suitable for high pressure application. This is economical, this is expensive. By this, I would like to say that the topics for this has been already completed. So thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.